Mhm.
Okay. Um, what is this again? Sorry, I just like
Okay, so see,
yeah.
that's these are two molecules.
Which are in staggered form? Or sorry, Newman projection. Yeah.
Yes, it is a Newman projection. Okay, so there
Yeah.
is, let's suppose this is a green color struct. This is carbon, first carbon, and this is the second carbon. Okay.
Mm-hmm.
Now, in Newman projection formula, how we'll see the compounds. So see, what we are going to do, we just put these structure like this.
Mm-hmm.
Hmm?
Yeah.
How many carbons are you able to see in this case?
How many carbon? Just this one, right?
Yeah, just this one. So we represent the first carbon with a dot only, okay?
Mm-hmm.
And the backside carbon, we will represent with a whole sphere. Okay.
Okay.
Now, with the first dot carbon, how many bonds are there with that first dot carbon?
This one?
Bonds. This
Yeah.
one, two,
Two, three,
and three.
four, five,
No, no,
six.
no, no, no.
Huh?
Only
Oh,
three.
sorry. Just
For the front
oh,
carbon,
sorry,
we are
sorry.
having only three bonds. Okay. Now, from the backside carbon, how many bonds we are having? Three. So we attach three bonds to this structure. Okay, these three bonds. Okay. So this is a staggered form or eclipsed form.
Wait. I thought you said there's only one carbon. Where did the other carbon come from?
The other carbon is behind that carbon. Wait a second, I will show you again.
Oh, okay, okay.
Okay. Now,
Oh, okay, okay, okay.
in
Yeah,
Newman, we
yeah.
will represent these carbon or the molecule
Mm-hmm.
like this, that the backside carbon we are not able to see.
Mm-hmm.
Okay. In eclipsed conformation, we are not able to see the back bonds also. Okay. This is staggered
Mm-hmm.
form. Let's see if I'm having one. Okay. No, it's going to be a little tough. Do you understand now, like how the exact structures will
Mm.
show in the staggered and eclipsed form?
Yeah, like there's three in front, three in back, right?
Yeah. And
In
in
different ways.
eclipsed form, all the three which is in
Mm.
front are having a parallel in the eclipse, like the back card.
Mm-hmm.
Okay. Now, to convert Newman into Fisher, we need eclipse conformation. We discussed that part also, that in case of Newman, we need eclipse form to convert this eclipsed form into Fisher. Okay. Now I'm giving numbering to these compounds first, second. Okay. So what I'm going to do, I just just represent a structure. Okay. Fisher structure, which is having two carbons. Okay. One and two. The first part always come on top. Okay. Second part always come on here. Then I'll attach the third and fourth numbers to that same carbon which is having first group. Okay, so I'll attach third and fourth. Third is in the left side, so in Fisher I also write third in the left side. Third, fourth, and here is fifth and sixth. So I attach fifth and sixth to the same carbon as the second group is attached. Done. So that's
Mm.
how we can represent Newman to Fisher. Okay, now I'm giving you a question. Okay, and you needs to
Wait, sorry,
convert. Yeah.
sorry, I have a question. Um,
Yes.
so why is one here and two here when they're both like here together? You know what I mean? Like,
Yes, but see, they both are having different carbons. Okay, they are
oh,
attached
right,
to
right,
different
right.
carbons.
Yeah.
Yes, and there is only two carbons, so I need to represent them at different carbons.
Mm,
Okay.
yeah, it's just hard to visualize at first. It takes some time, I think, right? Yeah.
Yeah.
Yeah, but that's pretty clear. Yeah,
hmm
thank you.
Now I'm giving you a question. Okay.
Mm-hmm.
Mm, Okay. So let's suppose I have. Okay. Now convert this form into the Fisher one.
Okay.
Yeah.
Let me choose a darker color. Okay. Let's do red. Okay. Hmm. Okay, I'll have to think for a bit. It's a little different than the first one. Because this isn't
Mm,
staggered, right?
yes, it is staggered. We need to convert the staggered in eclipsed first.
Oh, right, right, right. That's why we're doing this whole thing. Sorry.
Mhm.
I like forgot. Okay. Wait, sorry, ma'am. Can you move it a bit up because I can't see the top part of the eclipse? Oh, it's one and two. Oh, wait, that we're not even using that. I'm sorry.
Yeah.
I don't know what I'm saying. Okay. Uh, so will we move it like, how do I do it? Huh? Do I follow the model that you made in the first one? Is it the
Mm, there is there is no rule to to rotate this in clockwise or anti-clockwise. You can rotate by yourself, by your convenience.
oh,
Yeah. So anyway, you can write down that. See, I'll attach
okay.
here. Now you can. Oh, sorry. We need a staggered form now. So
Yeah, no, it's okay. I can try myself.
okay, good.
Mm, mm, mm. Mm. Oh, I see. Mm, I don't know if that's even correct.
hmm
No, I think that's wrong. Wait, no, 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 sorry.
It's right.
Huh?
Yes. Why
It's
it is?
right?
Yeah.
Wait, it's right? Okay, that's good. Okay,
Now convert this form into the Fisher one.
okay. Is that correct, ma'am?
Yeah, it's correct.
It
Now
is.
you, yeah,
Yes.
now you needs to, okay, you needs to give, okay, so how you're writing? It is a first, and this is second, third, fourth, fifth, and sixth. Okay, now hydrogen, hydrogen, CH3. Oh, sorry. Here is Br will come. Br and OH minus. So here is Br. Here is OH, CS3 and CS3. Okay. Now,
Mm-hmm.
in this case, we will start the R and S configuration. So identify the R configuration for this compound and for this carbon and this carbon both.
Okay.
Yeah.
For which one? The oh no, the bottom right? Okay.
Yeah.
RNS, let's see. Okay. Wait. OH, no. Did that wrong. I think it's this one. Mm, I have a question. Are the halides heavier than like oxygen, nitrogen, like those elements?
Nitrogen.
Like oxygen, nitrogen,
Uh-huh.
right? Like, are
What
the
are you like?
halides like
Which
are
one?
heavier? The atomic mass is what I'm asking.
For bromine?
Yeah.
Bromine is heavier. Then the first halide is fluorine, then chlorine, then bromine.
Yeah.
Yeah. So bromine is having 100 and above mass, I think so.
No, no, no. I understand. I meant compared to like
Yes, yes, you
oxygen,
are
right? Yeah,
giving
yeah.
correct priority.
Oh, okay.
Yeah.
Wait, sorry, I have a question. Can you tell me which commonly like elements come up like that I need to know for atomic mass? I don't know, like, and compare them so that I
You,
know how to like prioritize.
yes, yes. You
Okay.
doesn't need to remember the atomic mass exactly, but only you needs to know that is it the given element having more mass as compared to another. Okay. So this is for halides. Okay. Majorly
Mm-hmm.
halides and OH and nitrogen containing compound will come. So in that case, you doesn't need to remember the atomic mass.
No,
Okay.
I understand, ma'am. I'm
Yeah.
not talking about halides. I'm talking about other, elements that come up. Do you understand like
In the
oxygen and
stereo, in the stereochemistry portion,
yeah.
in stereo there is like I don't think so that there is another compound will come except fluorine, chlorine, bromine, iodine, nitrogen, and oxygen. These are the only compounds.
Nitrogen.
Yeah,
Compared to
nitrogen.
oxygen, which one's greater? Oxygen and nitrogen between them?
Nitrogen is having more priority. Oh, sorry, oxygen having more priority
Oh,
as compared to nitrogen.
okay, so these are the main ones, right? These are the only
Yes.
ones pretty much.
Yeah. Yeah.
Oxygen is always
And
greater. And then
sulfur also. Sulfur having more priority as compared to nitrogen and oxygen. Yeah.
so I'm just gonna remember sun, S-O-N, sun, like a sun.
Yeah.
Okay, that helps. Okay, all right. So let me just sorry, let me do the bottom. I think. Oh, wait, CH3, CH3, right? CH3, CH3. This would be one for the back carbon.
Correct.
Okay.
Can we
A
do
C.
R and S for the second one, like the bottom one?
No, 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 we can't. I
Yeah.
just forgot. It's
Yes.
achiral.
Yes.
Nitrogen and nitrogen.
Absolutely. So the above one is R configuration or S configuration?
The above one. Oh, let me do that.
Hmm.
Oh, let's see. So it's like this. So this way is R because it's clockwise, right?
Mhm. Do we need to
Yeah.
change?
No.
Absolutely. Very good.
Okay. So then
I
this is
think
not okay.
hmm, this is R and clockwise. Okay.
Hmm.
I think now we understand how we can convert a Newman to Fisher. Can I give you more examples?
Yes, that would be great.
Okay. Mhm. Okay, so I'm giving you a little bit different example. In those example, you need to identify that the given two Newman projections are enantiomers or diastereomers. Okay,
Okay.
let's start. Okay, so let's suppose I'm having HCS3Cl, mm, hydrogen, CH3Cl, and here is CH3Cl and hydrogen. And let's suppose here is hydrogen, Cl, Cl, CS3, CS3, and hydrogen. Okay, now you identify that the given compounds are like, do they have diastereomers or enantiomers?
Okay.
Hmm.
Just based off of this, or do you want me to make a Fisher?
If you can identify by these Newman projection only, then there is no need to form Fisher.
Okay. Is it easier with Fisher, or is it like,
It is easier with Newman only.
Oh, okay.
Yeah.
What do you want me to do? Like, sorry,
To
absolute
identify that
configuration?
the given structures or projections are enantiomers or diastereomers or identical.
Oh, okay.
Mhm.
Oh yeah, it is easier through the structure. Let me see. Mm, hydrogen, hydrogen. Okay. Then
Thank you.
CO. No, this is also flipped. This is also flipped. I think it would be an enantiomer.
Yes,
Oh wait, hold on.
absolutely.
Yeah.
Yeah, yeah,
Okay.
they are enantiomers.
Okay.
We can identify. They are mirror images.
Yeah.
Yeah. So these are enantiomers.
Yeah, and these atoms like are a certain distance apart, right? Like this equal distance. That's how I
Yes,
was
yes.
able to tell.
So we can, yeah, we can identify directly from these structures. But sometimes if the one form is in staggered and one form is in eclipsed form, so from that
Mm-hmm.
maybe you are not able to identify directly. So in that case, you need to generate R and S for them. Okay.
I see. For which one's Fisher and which one?
Like if the compounds in one is in staggered form and another in eclipsed form.
Oh, okay.
Let's suppose I'm giving these two example, but this form is in the staggered and this is in eclipsed. Okay. So firstly, what you are going to do, if the compounds having same elements and there is any probability to solve that, so in that case you need to convert eclipsed into staggered, or you can convert staggered into eclipsed. Okay.
Okay.
Okay. So I'll give you one more example in which you need to identify that the given compounds are chiral or not. Okay.
Yes.
After this class, you solve the PDF that is for
Mm-hmm.
stereochemistry answer key. Okay. That
Mm-hmm.
PDF contains like all sort of examples which you need to solve.
Mm-hmm.
So I don't think so that after that PDF solving you have any issues.
Mm. And stereochemistry, right?
Yeah. The PDF name for stereochemistry answer key like that.
Okay.
There's three PDF which I share, but the
Mm-hmm.
four stereochemistry answer key medium PDF that is like more important.
All
Okay.
right. Okay.
Okay. So do you have any doubt in Newman? Like how we convert Newman into Fisher or anything related
Wait,
to
sorry.
Newman? Yeah.
With, uh, with regards to the other documents, which ones are higher priority?
The first one is for four stereochemistry answer key medium PDF. Then
Mhm.
second you can solve chapter CH5 stereo 2 that part. But I don't
Okay.
think so that you can solve all these PDF in a day. So you'll start with the four stereochemistry answer key that PDF.
Okay.
Yeah. So after solving that, I think you cover all the topics.
Mm.
So there is one more thing
Okay.
which you shares with that we can discuss also that the chair conformation changes.
Yes.
Mhm.
Yeah, I relayed my questions to Sir. I think he probably
Yeah,
sent it to you.
yeah.
Yeah.
Chair conformation. In case of chair conformations, and IUPAC name to Fisher. What does like
Remember the examples we did yesterday where we had to make a Fisher out of the name of the molecule?
IUPAC name, na? Okay, okay.
Yeah.
So yes, we didn't do that. So maybe you are facing a little issue in that.
No, no, no. We did do those, ma'am. I think we did them.
Okay, okay then.
But I
Okay.
think I need more practice. Remember, it's
Yeah.
like chloropentane or chloro something like that.
Mm-hmm.
Like, yeah,
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 yeah.
yeah.
So there's only one topic which I needs to cover up in stereo, that is a chair confirmation. Okay.
Okay.
Okay, let's start with chair confirmation. Can you erase all these things?
Yes. Oh my God.
Give me a second.
It's not erasing for me. It's so odd. Sometimes does that. It's really irritating. I'm so sorry to have this on your
Okay, I will
have
stop
this
the
on your.
screen and then we will do it.
Okay, I'm so sorry, ma'am. My pen's like not working. Feel bad. Yeah, I'm trying to erase. Nothing is working. I'm so sorry. Hello, is everything okay?
Yeah, yeah.
Oh,
I'm just searching my notes, but like I think they are.
I'm sorry for the new topic.
Yeah, the chair
Oh,
confirmation.
oh,
Okay, so I will stop the screen.
oh, sorry. I thought because of my work you couldn't like do anything. That's why I was like saying sorry because I don't know.
No, no,
My bad.
no.
I think I misunderstood.
That's not a
Okay.
issue. You need to like study all these topics because they are important. But
No, no, no. What I'm saying is like my ink wasn't erasing on your board, so I thought you needed to use that
oh,
space or
okay,
something.
okay, okay. No. Okay. So we will start with the confirmations of cyclohexane.
Okay.
What is cyclohexane?
The cyclic structure, right? Six membered ring.
Membered, yeah.
Yeah.
Okay. And what do you know about cyclohexane?
Cyclohexane, it's rotating. Is it aromatic?
Cyclohexane is not aromatic.
Um,
The structure of cyclohexane is like this.
uh,
Okay. This is cyclohexane.
yeah.
So let's start that how many types this cyclohexane can be present. Okay. So there is four types, that chair, twist boat, boat and half chair. I will share a picture with you. Sorry.
Wait, sorry, ma'am. Is a benzene ring different? Maybe I'm thinking of that. Is that different?
No, benzene is different. Benzene is having double bond and aromaticity.
Oh, that one. Okay, this is completely different. Okay, sorry. Yeah.
Yes.
Hexane, ane. That means one, right? One bond. Single bond.
Yeah. All
Okay.
the carbon having single bond.
Okay.
Okay. And I'm sharing the screen again. Okay. So I hope you can see this 3D structure. Hmm?
Yeah.
Okay. So this is the 3D structure of chair. You can write down that
Mhm.
uh, the chair form and boat form are a little bit into the stable form of cyclohexane, chair and boat form. Okay. So the chair form looks like this and boat is like this. Okay. And there is one more structure that is half boat. Okay, so half boat will looks like this. This is like the only upper part of the boat is on the upper side, while this part is on the same plane. Do you understand by half chair?
Half chair?
Yeah, half chair structure. See, this is the chair structure of cyclohexane. This is boat structure, and above here is a half boat
Mm,
structure. Okay.
okay.
Okay. Now the next term that is that is more useful to us, that is the chair conformation. Okay,
Okay.
like how the chair conformation will looks in the 3D form. See, see this molecules. Are you able to see this molecule?
Mm-hmm.
If I'll represent this molecule as like this, so don't you think it looks like the cyclohexane?
Yeah.
Hmm? Yes, but the
Mm-hmm.
exact structure is this one. Okay, so this is cyclohexane only. Uh, okay, so
So there's what, chair, boat, and half chair, eh? Sorry, I'm still writing it down. Which one did you say is the most stable?
chair conformation is most stable.
Most stable. Okay. Wait, so what are all these structures discovered in a lab or something?
Yes.
Oh, okay. So from the lab, they were able to determine that chair is the most stable?
Yes, like
Or
they are differentiate on the basis of time they are present.
time?
Like if let's suppose if there is a molecule in the lab,
Mm-hmm.
okay, and they will there is like there is a little bit a newer compound, okay, and we
Mm-hmm.
need to identify that which is more stable. So what we are going to do,
Mm-hmm.
we take those example in a test, and the element which is most stable is present at the last time, okay, and the compound which is not stable and which is having a little bit less stability, they they maybe react with someone which we are used in the reaction, okay. So the stable compound is doesn't react.
Hmm. Doesn't react as much.
Hmm.
I'm just writing. Yeah, I wanted to know for my own knowledge because I'm interested in this field. So, yeah,
Okay, okay,
like
so now
pharmaceuticals and stuff
mhm,
like that. Okay.
yeah, you can write down. Now you
Okay.
can make a structure also for this chair conformation.
Mhm.
So see how the chair conformation looks. Let's suppose this
Mhm.
is the carbon. Okay. This is attached with this carbon. And then here, here. This carbon attached here backside. This, this. So can we represent this structure like this? Hmm. Okay. So now do you understand like how 2D conformation or 2D structure of chair looks like?
Yeah.
Okay. Now, now we'll go to our OneNote page.
Wait, sorry. Let me look at that for 1 second. The 3D one.
Yeah, yeah, you can. And you also take a screenshot for this one.
Oh, okay. Wait. Hold on. Give me 1 second. Oh my God. Why is my tablet not screenshotting? Give me 1 second. Okay. Got
Okay.
it. Yeah. That's so interesting that it looks like that in 3D.
3D is more interesting as compared to
Yeah.
2D. Okay. So now we'll make a structure of cyclohexane. Okay. That is mm, okay. So now this is the 3D structure,
Okay.
okay, of chair conformation as we see. And you can also draw like this also, okay?
Okay.
So both of them are interconvergible, okay? They are is basically they are in equilibrium with each other. Now the major thing that is comes
Okay.
like how we can represent the axial and equatorial bonds.
Mm-hmm.
Okay, that these are like the axial and equatorial bonds are very important.
Mm-hmm.
So what we are going to do, we just firstly make a simpler structure formula. Okay, and in this structure, the bonds we are going to alternate. Okay, let's suppose we firstly add straight bonds. That is, let's suppose this is the straight bond. Okay, the first one,
Mm-hmm.
and then we add the next bond over here. Okay, then we add one bond here. Okay, so
Mm-hmm.
there is three bonds on alternate carbon. Yes or no?
Yeah.
Yes. So these are axial bonds. Then we'll add the three bonds over here. These three bonds, which is on the lower side or bottom side, they are also axial bonds. Okay. So this is a representation of axial bonds. Axial bonds. Okay. You can also make
Mm-hmm.
them into the wedge form. Okay. Wedge form. Because they
Okay.
are above the plane form.
Which ones are the axial?
The white bonds which are formed. Okay. So there is total six
Okay.
carbon in the cyclohexane. Okay. And
Mm-hmm.
each carbon having one axial bonds.
Mm-hmm.
Okay. Then we need to identify that what sort of bonds are axial bonds. So we will firstly make a chair conformation, a chair form. Then on the chair form, there is three bond which is above the plane or upper the side. and three bonds which are below the plane or bottom side. Okay, so those
Okay.
bonds are axial bonds. Then, hmm,
At the bottom? Okay, yeah.
okay, the three bonds which are bottom side. Any doubt up in axial bonds?
Wait, which one's up and which one's down? Like in the middle carbon? Like here? Sorry, give
Right.
me one second. Here?
This is the upside, see, and this bond
Mm-hmm.
is in the lower side.
Yeah.
Then this bond again is in the upside, and this
Mm-hmm.
is also in upside. Okay, this is in the lower side, and here this one is also lower side.
Oh, for the first. Okay, okay, okay. For the first one, right? Carbon?
Yeah, we will start
Oh,
with.
okay.
Mhm. Okay, we will start with this carbon. Okay, this first carbon.
Mm-hmm.
Okay, after first, second is not on upward, third will on the upward side. Then fourth is downward, fifth is again upward, and sixth is again downward. Okay.
Mm-hmm.
Okay, so these bonds are axial bonds. Then the another terms come, that is equatorial bonds. Okay, there is two types of bond in this cyclohexane form. The next bond is equatorial. Okay, so now again we are going to form a chair structure. Okay, and okay, so in case of axial structure, we are going to form this one and this. These are equatorial bonds. Okay,
Mm-hmm.
and then here is the another bond, and these two bonds. Then the remaining bond, which one? Okay, this one. Okay, so these bonds are equatorial bonds. Then
Okay. Wait,
how?
ma'am, do you have to draw the structures very precisely?
Yes,
Oh, how do I know that? Oh,
like how I'm drawing. So see,
yeah.
we need a structure like this. Okay. Now, what we are going to do, we add axial and equatorial all bonds. Okay, in the same structure.
Okay.
Okay. So now see the trick which I'm using. I'll first draw all the axial bonds. Okay, because all the
Mm-hmm.
axial bonds are a little bit easier. Okay. So firstly, how I will start with axial bonds, I'll giving numbering to this carbon as a first. And of the first, it is always above the plane. Okay.
Mm-hmm.
Then in the second carbon, it's below. Above, below. We only needs to do this. Then this one having above the plane. Okay. Then again this below the plane. Then this carbon is having above the plane structure, and this is below the plane. Done with axial bonds only. Hmm?
This is for axial. Oh, axial. Okay, okay.
Axial. Then I will add equatorial. Okay, equatorial as like the axial bonds start from above side, like upper side. So sorry,
No,
equatorial
it's
will
okay.
start equatorial from start with like the bottom side. Okay, then bottom, then This will on the above side. Oh, sorry. Wait. These are not on wedge side. The equatorial bond is on the dash side. Okay, dash side. This is on this side. Then here is this side, like this. This. Do you understand?
Yeah, what I meant, ma'am, was like the actual image itself. How do I explain it? The structure, the full structure. Do I have to draw it very precisely, is what I meant. Like this base structure
Mm. See,
is
in the structure, you need to know that what bonds are axial and what sort of bonds are equatorial only.
oh,
Okay.
that's
So
all.
let's suppose I'm giving you any example, and those example needs to know that the given bond is axial or not only. Okay, let's
Okay.
suppose I'm giving an example if I have. Yes. So you can erase this structure.
Okay.
You only needs to know axial and equatorial. Okay, let's suppose I'm giving you a question that here is the CS3, 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 CS3. Okay, these are some questions. Now you tell me that in the first one, let's suppose this is A, this is B, and this is the C. Okay, these are the
Hmm.
structure. Now you tell me that in the first case, the CS3 on axial bond or equatorial bond?
First case, I would say axial. Or no, not. Yeah, axial.
Yes, absolutely, it is on axial. Then in second case,
Equatorial.
yeah, and the third one
Mm, both.
having
Top
axial,
one,
yeah,
yeah, axial, and then here equatorial.
absolutely. Okay, so now do you understand how we identify axial and equatorial bonds?
Yes.
Okay, good.
So which one is more stable, axial or equatorial bonds?
Equatorial, see, bonds are not stable. The atoms or the groups attached to them, that is stable. Okay, so
Okay.
majorly, the larger size group are stable on equatorial bonds.
Oh, sorry. Can you say? I
Yeah,
wanted
I
to
can
take
write
notes on what you're saying here.
larger group stable on equatorial position. Okay, so let's suppose I
Yeah.
have one at one side I am having CH3. Okay, and on another side I am having tertiary groups like it's butane. Okay, one is methyl
Mhm.
and one is butane. So butane needs to go at which position, like on the axial or equatorial? Butane.
Butane. Butane. Okay, that's a bigger group, right? So they would
Yeah.
be on the equatorial
Butane is on equatorial. And what about methyl?
axial.
Yeah, axial. But if possible, if there is by any chance, methyl can also be on equatorial, then it will also prefer equatorial. Okay. Is there any vacancy on equatorial position? Then it will also go on equatorial. Okay. So firstly, we
Okay.
prefer equatorial.
Hmm.
Hmm.
Does it have to do with steric hindrance?
Yes, it's a steric hindrance. It's a 1,3 diaxial interaction. There is two terms will come. Okay. So what is 1,3 diaxial interaction or steric hindrance?
First and third carbon, right?
Post. Absolutely very good. How will tackle with these?
Um, let's see. Here, this is first. No, it's not, right? Never mind.
Hmm?
Wait. I can label these carbons the way
Yeah.
anyway. Right? Okay. Um, 1,3 diaxyl. Well, this is just one. There's nothing on three, right?
At give me a second. Mhm. Yes. Yes. Okay. Yeah. There is not any compound on the third. There is hydrogen only.
Mm-hmm. Is everything okay, ma'am?
Yeah.
Oh, okay.
Uh,
So the diaxial interference or steric hindrance is mainly with axial. Oh, diaxial means with axial. Of course, that's
yeah.
obvious. But then steric hindrance can be between any groups, like
Yes.
any sort of bonds.
Yeah.
Equatorial, axial, it doesn't matter, right?
No, no, axial bonds. We need
Only
axial bonds.
axial does steric hindrance.
Let's suppose. Okay, so we will discuss that. Mhm. 1,3 diaxial interaction. Okay, so let's suppose I'm having this compound. Okay, and at which centers 1,3 diaxial will perform? These three, in between these three. Okay, if all these three dotted carbon having hydrogen, in that case there is no any sort of 1,3 diaxial interaction will be there. Okay, but let's
Okay.
suppose if these are having hydrogens, okay, and this group is at this position having axial a CS3 group on the axial position. Okay, so in that case CS3 is in the larger side, so they are facing diaxial interaction with both these hydrogens. Okay,
Mm-hmm.
you understand what is diaxial interaction? Diaxial interaction means when the two axial bonds are interact with each other.
Mm.
Usually interaction proceeds just because of steric hindrance, the size, okay, if they are in the lower size or the smaller size. So in that case, there is not any sort of 1,3 diaxial interaction would prefer. Okay, so that's why I told you that the larger group stable on the equatorial. See, on the equatorial.
Mm.
Let's
Is this the
suppose
only form of steric hindrance?
no, no, there is a lot type of steric hindrance. See.
Like in this chair confirm or okay, never
Yes,
mind.
in this chair conformation, only these two interaction will be present. The first one and this is the second.
Oh, okay.
Only these two. And let's suppose if I'll put the CST on this side, okay, in this side. So in that case, is there any 1,3 diaxial interaction present?
Uh,
No,
no, right?
no. That's why the group prefer the equatorial position as compared to axial position.
Mm,
Okay. I'll give you one
okay,
more example. You can ask.
okay, I have a question. So, why do we have two different positions on one carbon like that?
Like axial or equatorial positions,
Yeah,
they are not positions, they are like the bonds, which is a chair conformation of cyclohexene have.
oh, I see. Like this specific confirmation. Okay.
Yeah, like the chair form of cyclohexane is a practical thing. We like discover that a cyclohexane present in this form, chair form. Then in chair form also the groups are present on the equatorial, not on axial. So that is also a practical thing. We discovered that. So on the basis of that discovery, we assume that there is 1,3-diaxial can be possible. Okay.
Okay.
Yeah. So that's how this.
Also, I have a question. Is this mainly important for like reaction mechanisms?
Yes, they are very important. Like how?
Okay.
See, yes. See, uh, okay. So let's suppose there is any reactions they will give you, and they'll ask you that there is two probability to compound form. Let's suppose this is A and this is B. Okay, they'll give you two examples,
Mm-hmm.
and both can be formed in the reaction. But they ask you that which is more stable, which is like a major compound. So how you understand, like how you identify that given compound is major or not. So for that you needs to know that
Mm,
in this case there is no any 1,3-diaxial interaction present. So that's why this structure is preferred over this one. Okay, there is a lot of reactions
oh.
in which we are going to discuss stereo of that reaction.
So this is
Okay,
related to stereochemistry as well. Okay.
yeah, the stereo which we discuss is a basic
Hmm.
stereo. Okay, which we
Okay.
need in further classes.
Oh,
Hmm? Okay.
all right. So I just wrote that down for reaction
Yeah.
mechanisms, major and minor. That'd be useful to know.
Mm.
Like an SN1, SN2, E2,
Yeah,
E1, E2.
in case of SN1, these are very important.
Okay.
Okay. So you can also write down the stability of conformation of cyclohexane. Okay. That is also very important.
Okay, yeah, I wrote those down. Oh, right, because in SN1 you have a carbocation intermediate.
Yeah. Yes.
Yeah, that's very important.
Sorry.
No worries.
The chair form is more stable than twisted boat, then boat form, and in the end, half chair. Okay. This is the stability trend. Then Then there is a
Mm-hmm.
structure, that boat structure. Okay, I'll draw that boat structure as there is axial and equatorial bonds in case of chair form. There is flagpole hydrogens in case of boat conformation. Okay,
Okay.
sorry. So this is a boat structure. Okay. Oh, sorry. Yes. Mm, yeah. So see, there is two hydrogens over here,
Mm-hmm.
like this. So these hydrogens are causing a steric hindrance to each other. So these hydrogens are, and also these hydrogens are on the top of the structure. So these hydrogens are known as flagpole hydrogens. Flagpole hydrogen. Okay.
Mm-hmm.
These are some terms which you need to know. Then, yes, these are the major conformation in case of cyclohexane. And yes, sometimes in cyclohexane you also needs to know the R and S configuration and enantiomers and diastereomers. Okay, so we will tackle these type of question also. Wait a second. Okay, okay. Let's suppose they will give you like the structure, okay, and they told you to identify CS3 over here and CS3 over here. They told you to identify the R and S configuration for these compounds. So how you
Mm-hmm.
identify
How we'd identify,
R and S for these?
yeah, isn't that a lot easier to do?
Huh?
It's a lot easier to do, right? Like you just prioritize the groups, each carbon.
Yeah,
Oh, do you want me to do it myself?
yeah.
Okay.
Do I need to make a chair confirmation for this one?
Mm, I don't think so, no.
Yeah, good. So we can directly from the given structure can
Mm-hmm.
identify, okay, in the cyclohexane form.
Mm-hmm.
Okay. Mhm. Let's suppose there is a structure. So OH over here and CS3 over here. So how you identify R and S for this one?
Okay.
Hmm.
R and S. Mm. Isn't it just like, no, oh wait, one, two. I think there's four different groups like here in this carbon. You
Yeah.
have OH. Yeah.
So see, in this case, how you identify? Now, in this case, in you need to know that whenever the group is on the axial side, the
Mm-hmm.
above side, upper side, then the bond is axial, like axial, not it is on wedge direction. Okay, so you'll represent that sort of group as a wedge. Okay.
Mm-hmm.
And if the group, any group is on the downward side, then you can represent that group as dash. Why I told you this? See, let's suppose there is OH. So there is only three valency of carbon will completed. Okay. So I need to attach one hydrogen over here. Okay.
Mm-hmm.
Now I'll start to give priority. This is first, then here is the second one, third, and fourth. Done. So first,
Mm-hmm.
second, third. Is it clockwise or anti-clockwise?
Anti-clockwise.
Yeah, anti-clockwise. So it is S. Now the main thing that do we need to change the configuration? So fourth group on this side. So how we identify that
Mm-hmm.
the fourth group is on wedge side or dash side?
I think that would be equatorial, right?
Equatorial, absolutely. Oh, wait.
If it's on dash side, you have to change it, right?
So in
The
this case,
configuration.
yeah, in this case, you doesn't need to identify equatorial or axial. You only needs to identify that there is two bonds only in the cyclohexane ring, that carbon having that bonds are not included in the chair form. Okay, let's suppose one is OH and another is hydrogen. Okay, so OH is upward side. Can you see upward side
Yeah.
OH? So this
Mm-hmm.
group is on the wedge. Okay, and hydrogen is in the downward side, so this bond is on the dash. Okay.
Mm-hmm.
Okay. So fourth group is on the dash side. So whenever the group is on the dash side, we doesn't need to change. We know
Yeah.
this.
Oh, wait, I thought it was the other way. Oh, no, dash we don't need to remember. Sorry, I'm confusing them again.
Okay.
I forgot.
Okay. Now let's start with this one. Okay. Here and here is a CH3 and this is a chair form and here is the again a chair form. Okay. And one hydrogen over here. Any doubt in this?
No.
Let's start to give priority now. This will be the first, second, third, and fourth. Okay. Now I need to rotate clockwise or anti-clockwise?
That's clockwise.
Clockwise. Clockwise
Yeah.
means R. Do I need
Mm-hmm.
to change? Now see fourth group. Fourth group is on wedge side or dash side. Now you tell me.
Mm, dash, sorry, on the bottom carbon, right?
Mm-hmm.
Mm, I think it's gonna be wedge, right?
Fourth group.
The fourth group.
Hmm. See the direction of hydrogen, the direction of bond where the hydrogen is attached. What do you think? The bond is going upside or downside?
Because you have CH3, that's gonna be
Down.
I don't know. Oh, down, yeah. It's gonna
Yeah.
be down.
So the hydrogen is on the upside. Upside
Yeah,
means
upside.
it is on wedge.
Wedge.
So do we need to
Yeah.
change? Yes, we need to change. So this
Yeah.
is a S configuration. Do you understand?
Yeah.
Great. Now what you are going to do, you do some practice questions. Okay. And
Okay.
in next class we are going to ask your doubt and if possible we will start our next chapter. Okay. Now you can
Yeah.
ask me from today's class anything you want. Any issue, any doubt.
Mm,
Hmm.
no, we covered chair confirmation. Oh, I think chair flips will come in my syllabus, I'm pretty sure.
Sorry, chair confirmation?
Flip, like chair flip.
Chair flip.
Mm-hmm.
So this is the only form with
Like